Hello everyone, welcome back to my channel. Today we will be solving Leetcode problem 1780. Check if the number is sum of powers of 3. Okay, what does the problem statement states? Okay, given an integer n, return true if it is possible to represent n as sum of distinct powers of 3. This is something which we should notice, sum of distinct powers of 3. Okay, otherwise return as false. Okay, an integer y is power of 3 if there exists an integer x such that y is equal to 3 power x. Okay, so they are basically saying, okay, is 9 a power of 3? Yes, 9 can be written as 3 square, right? So that's the reason 9 is a power of 3. Okay, let's take an example, n equal to 12. Okay, for n equal to 12, the number 12 can be split into two numbers, right, which is 3 and 9. So here the number 2 is formed by the numbers which are powers of 3, right? 3 power 1 and 3 power 2. Okay, and 92 can be written as 3 power 0 plus 3 square plus 3 power 4, right? So yeah, so let's jump back to the editor and let me tell you what is the thought process behind this particular problem. Okay, so whatever number has been given to us, let's say n should be formed as a sum of distinct, okay, sum of distinct powers of 3, right? So can 21 be can 21 formed with sum of distinct powers of 3? The answer is no. The reason being, if you take 3 power 0 or 3 power 1, 3 square, 3 cube, 3 power 4, okay, which is 3 square is basically 1, 3 power 0 is 1, 3, which is 9, which is 27, and so on and so forth, right? So we should only consider these elements because 27 itself is greater than 21, so it cannot be combined with any other number which could result to 21, right? So can if we include one alone, can it form a sum of 21? No, right? So we have to include 3. We have two options, right? Either we can include 3 or we cannot include 3. Let's include 3, okay, and we have option to include 9. Okay, the entire sum is actually 9 plus 3, which is 12, 12 plus 1, which is 13, but it is not equal to 21, right? So we cannot form. Okay, the one other possibility is basically either we can include 1 or we can include 9, right? Either we can include 1 or we can include 3. Either we cannot include 1 at all, right? It would be 3 plus 9, or we can only include 3 or we can only include 9, right? Here the sum is 10, sum is 4, sum is 12, sum is 3, sum is 9, or we can only include 1, which is sum is 1. So any of these summations is not equal to 21, right? So 21 cannot be formed by sum of distinct powers of 3. Okay, so for any given number n, so what all numbers can be included to form a sum of n, right? Either we can include 3 power 0, we can include 3 power 1, include 3 power 2, 3 cube, 3 power 4, and so on up to some x, okay, some number, right? So 3 power x, if it exceeds n, that means we cannot include. So we should include a power which is less than n, right? So 3 power x should be less than n. Okay, x can go all the way up to some number whose overall power is actually less than n, less than or equal to n. Okay, so why I have taken equal to is because, let's say, if n is equal to 9, we can directly take 3 square, right? This number alone can form a sum of 9, right? We have 3 square is one distinct power of 3, right? So that is the thought process. Okay, now for every number we have two possibilities, right? 3 can be part of the solution or cannot be part of a solution, right? 3 power 1 can be part of a solution, cannot be part of a solution, right? So what I mean is basically, so let's take a, let's take number 12 as a, let's take number 12. Okay, so number 12 can be formed as 3 power 1 and summation of these two numbers, right? The solution set contains these two numbers. So here among these three numbers we have only included these two numbers in the solution, right? So we don't know exactly what all numbers we can include in the solution. Okay, we have to basically check each and every possibility. So that is the initial thought process. Okay, so either 3 can be part of solution or it cannot be part of a solution, right? So if 3 power 0 is part of a solution, okay, that means, let's say we have a function f which will tell whether n can be formed, okay, whether n can be formed by including 3 power 0 or not. Okay, if I include 3 power 0, okay, so let's say we haven't included 3 power 0, okay, that means we have to form a number with the remaining elements. Okay, so I will say I will have a the second parameter as power. Okay, okay, so what does this function tells is whether I can form n with distinct powers of 3 from power tills all the way up to x, right? So initially I will basically understand whether I can form n from 0 till all the way till power, okay, power all the way till x. Okay, and so if I don't include, if I don't include 3 power 0, that means the n is still the same, right? Let's take a concrete example. Okay, let's take, can 12 be formed from all the powers from 0 till x? Okay, so I can basically say, let's say I don't include 0 in the solution. So if I don't include 3 power 0 in the solution, the number will still remain the same, but I have to include I have to check for the powers from 1 till x. Okay, now if I include 3 power 0 in the solution, that means I have to form a number which is 12 minus 3 power 0 with the rest of the powers from 1 till x, right? So again here I can have two possibilities. If I don't include 3 power 1, so I have to form 12 with powers from 2 to 2 till x. Okay, if I don't include, if I include, so if I include, that means 12 minus 3 power 1 from powers from 2, right? Again here I have two possibilities. If I don't include, 3 power 0 is 1, right? So the value would be 11. Can 11 be formed with powers of 2 and above? So I am not including 3 power 1. So if I include 3 power 1, so 12 minus, can 12 minus 3 power 1 be formed with the powers from 2 till all the way above? Okay, so again this is, if I don't include 2 in the solution, can I form with all the powers from 3 and above? Okay, okay, again here, can I form, if I include 12 minus 3 square, comma, can I include powers from 3? Okay, so here actually if you see 3 cube itself is greater than 12, right? So we have to basically say it cannot be formed here. Okay, this would be the base case. Okay, so this would be the base case and we would basically written as false. Okay, now can 12 minus 3 square, which is 9, right? Can 9 be formed with 3 power 4 and above? Which is no, again we'll written false, which is basically, if I include again here this is basic. If we solve this, which is basically 12 minus 9, which is 3, can 3 be formed with a number from using 3 cube and 3 power 4 and so on 4? Can 3 be formed with these elements? Which is no. That's the reason we'll again return it as false. Okay, from this tree. Okay, so okay, again we are again back here. Okay, so this is basically, so again at this particular point of time I have two possibilities, right? Can 12 minus 3, which is 9, can 9 be formed with powers of 3, or can 9 minus 3 square, which is 9, with the rest of the elements, which is powers from 3 and above? Okay, so this is 0, right? Once we reach 0, this is our base condition, right? So we have actually formed the desired number using all the distinct powers of 3. So from here we'll return as true. Okay, so again this will again return as false. Okay, so the overall solution, this will return as true, and that will be carry forwarded to the parent and will be parent, and our parent will basically return as true. You understood, right? At every level I am taking two decisions. Okay, at every level I am taking two decisions. So there will be total it can go all the way up to 3 power x, which is which should be less than n, right? So x should be n log 3, so it can go all the way up to 2 power n log 3. Okay, so the overall time complexity will be order of 2 power log n log 3. Okay, so you understood, right? The base case will be if n is actually equal to 0, that means we have to return as true in our recursive calls. Okay, if it is not equal to true, or if n is greater than if n is less than 3 power x, right? So we have reached a number which is actually greater than x. That means we have to return it as false. Okay, so let's jump back to, so you understood, right? F of n comma 0, we will be, every time we will be taking two decisions, either to include or not include, right? Let me generalize this thing. So f of n comma power, I have two possibilities. If I include the respective power in the solution, right, that would be 3 power and power plus 1. Okay, can this form a solution? Or if I don't include the power, it will be still the same number, but I have to form, can I form with the rest of the powers, like power plus, from power plus 1 till all the above, can I form a solution or not, right? So this is our recursive relation. There are two possibilities at every step, right? Let's jump back to the editor and let's try to solve this problem. And the base case will be once n is equal to 0, that means we have to return true. If n is less than 3 power x, that means we have to, that means we cannot form the particular number, right? So let's jump back to the editor, right? Yep. So let me write a utility function which will basically check the power of, check whether it's a power of 3, right? As I said, can n, which will, this is our recursive function which will basically tell, can n be formed from power till all the way till x, right? With all these distinctive powers, can n be formed or not? That is what this function will tell, right? So I have two possibilities at any point of time, right? I can basically so I have two possible options, right? If I don't include the current power in my solution, so can I form from the next power till all the way till x, can I form the n? Or if I include the existing power, which is math dot power of 3 comma power, if I include the current power in my solution, so n minus the 3 power, can that particular number be formed with the remaining set of powers, right? So if any one of this returns true, that means I have to return true to my parent function. So what is our base case, right? If n is equal to 0, that means I can form my number, right? Or if math dot power 3 power, if it exceeds n, right? If the current power exceeds the given number, that means let's say n is 9 and the current power is basically 3, right? 3 cube, which is 27. 12 can't be formed with the 27 and the higher powers, right? That is when I will basically return as false. Okay, so all I have to do is basically call my function over here, return check power of 3, and I will start with 0 and I will recursively call my function. Let's try to submit the problem. There is some issue with the syntaxing part. Okay, so I haven't closed this. Perfect. Let's try to submit this. Again, I have missed something else, some syntax problem. Let's check it properly. It has, I passed 2 parameters, or check power. I have included one extra. Okay. What is this? Acha. Okay. So it says loosely conversion of double to integer. So the power function is actually returning and double. Okay, so let's typecast that. Let's include a variable called power, math dot power 3 dot power, and typecast it to int, right? And let's try to use this particular thing. Okay, I hope you are not getting confusing with the variable names. Let's try to submit. Perfect, it's working. Okay, let's say power of 3. Let's say power of 3. That just the naming thing, so that it will be, you can able to differentiate between this power and the other variable power. Let's try to submit our solution. It has passed all the basic test cases, right? Yep. Let's try to submit. Yeah, the overall all other test cases were also able to pass with our solution, right? So this problem is more or less similar to the subset sum problem. Okay, here we have a set of here we have a set of 3 power 0, 3 power 1, right? Which is 3. Let me write it on 3, 9, and so on and so forth. So we have to basically include all the distinct elements from this particular set in our solution so that it can form n, right? So it's more or less a similar problem of subset sum, right? Yeah, that's all about the solution. Thank you for watching my video. Do subscribe for more such videos. Thank you.